Hello. I'm very excited to be here. I really liked what Luke did, where he had Slack open on his phone and took questions from there, so I will be doing that. Please join my channel, discuss, and ask questions. Thank you for having me. I am super excited to be here. This is my third Monitorama and one of my favorite conferences to go to. So, eventually my slides will go up there, and I can have a visual aid. Great. Today, we're going to be talking about how observability can be like superpowers for your developers. I watched Into the Spider-Verse recently. Right? Great movie. I had very low expectations going in. And I really liked the idea that, first, that origin stories can, in fact, be different, even if you hear the same one over and over again. And I also realized that actually there are a lot of interesting things that can be told as superhero origin stories. And while it could be nice to imagine ourselves leaping tall buildings in a single bound, in reality, in our actual lives, it can still be a lot of fun to recast the sorts of things we do every day as the powers of our own in order to improve our lives in a practical way. I'm also one of the founders of Honeycomb. We practice what we preach. But all the ideas in this talk are going to be transferable or should be transferable to your current tools, whatever you happen to use. So, okay, what is the world we're in, and who are the players in it? Well, first, I'm Christine, and my dirty secret is I identify as a developer. This is the only call for participation in this. I'm sorry. How many folks in the audience primarily identify as ops, SRE, and infra? Okay. How about who identifies primarily as a developer or an engineer? People, cool. Okay, so that's actually a more even split than I would have thought. Awesome. So I'm a developer. And when I was a young developer, just starting out, one of the things I took a lot of pride in is that I was fast. I could take a spec, turn it into code, do all the things that responsible software engineers do before you commit, code review, commit, do it over and over and over again. And I was like, I'm awesome. And I actually got through a few jobs like this somehow before I met my first real ops person. This time I was working on a new component of a big system, and I was doing that my nice little moving fast development thing, and suddenly I hit a problem. And that nice little development cycle looked a little bit more like this. So the ops person came knocking on my door. And pretty quickly, I understood why certain unflattering stereotypes exist around these roles. They say things like this. You may know someone like this. And when someone like this comes to you and says that, you're like, you get really defensive, and you're like, well, my code was fine when I shipped it. As time went on and my relationship with that particular ops person improved, it became clear that, after all, yeah, okay, I and the rest of the devs who were shipping code were causing a lot of chaos in the system. We were the ones making lots of small, safe changes that we were just very proud of getting out fast, and causing a lot of kind of new, maybe not as well understood changes in behavior in production. There's a great Medium post linked at the bottom of this. It was published back in February, where an engineering leader at Expedia analyzed several hundred production incidents. He read through postmortem reports to identify triggers, not root causes, but triggers, the things that surfaced an incident, and found that change, unsurprisingly, was the overwhelming leader. Some of these changes were things like configuration changes or changes to the way the info was laid out. But we've already established here who the leaders of change are. And on a macro scale, right, our industry is changing. Our software systems are all changing. They're getting more complicated. The number of parts, moving parts are increasing. The number of possible interactions are increasing. And we as an industry are starting to realize we need to be able to ask new questions of our systems to keep up with all of these possible failure cases. But you all know this already. You here, attendees of Monitorama, maybe the folks along on this live stream, you're experiencing this firsthand. What I'm here to propose to all of you is that the unlikely protagonists of this superhero story are your developers, working with ops folks and building bridges instead of just getting angry at each other and pointing fingers and getting frustrated. I loved this talk, this slide from John Allsbaugh's talk yesterday, because it's such a visceral reminder that, okay, if this person over there is doing this thing I disagree with, if they are insisting on SSHing into that machine and tailing those logs in 2019, well, okay, why, right? Let's assume good intent and figure out if they're doing this thing because the tool that I want them to use feels unnatural. What can we do to make these tools feel more natural? What habits do they have in place that might be not that hard to accommodate? And how can they be empowered to be productive in a different way? And one of our theses is that if the first wave of DevOps was getting ops folks to code and automate their work, then the second wave has to be getting developers to own their code in production and through production. Oh. We've had some good lunches today. All right, wait. Okay, so if developers are the leading source of chaos in these systems, why are we casting them as the heroes again? Well, think about it. When we talk about doing things like test in production, this is something that developers are already conditioned to do a little bit already, right? In pre-production tests, you imagine a scenario, you define what you expect the behavior to be or the output to be. When the actual doesn't match it, and you're like, oh, okay, well, I've got to go investigate. I've got to go look at my code, see how it might be behaving, see if my inputs make sense. Imagine building a system that you expect to behave like Miko, and instead having it turn out to behave like Rocket. And so pre-production tests, you've got all these good habits, but pre-production tests, we all know it's not enough, right? They run in a CI environment, they don't capture the unpredictability of production, they ask a specific set question that might have made sense 3 years ago when you wrote the code, might not make as much sense anymore. But so many of the right instincts are in place. Writing good pre-production tests, it's all about thinking about how your code should behave and being able to examine and having to explicitly state those assumptions that might not be true when you're doing that investigation. And the more practiced we get at this, and doing this sort of thing in production is a lot of the same principles. And the reason this is important is that the better we get at this, the better we get at identifying those assumptions and investigating on that front, the better our code gets, right? Because we start thinking ahead to how something might fail rather than how something has failed. If we look back at this development process, and let's toss this one in for good measure, test-driven development was the first real movement that let us start putting a feedback loop in earlier in the cycle. Back when it was cheap, or earlier in the cycle when it's cheap to adjust from what you learned. And given how effective that became, what if we took some of these other steps, one other step really, is the one I want you to think about, and shifted that left instead? Because observability shares so much in common with testing that shifting it left can and should and does often produce the same result that TDD did. A lot of teams are already experimenting with this. This is a tweet from one of our engineers who had never been on call before joining Honeycomb. Because any time you put a developer, take them out of their comfort zone and put them in a place where they have to look at production. They're on a site reliability rotation, on-call rotation, maybe they're writing shotgun. It's a forcing function in a way to expose them to a new way of thinking and having to learn really quickly what real-world production workloads look like and how all the pieces fit together. And finally, how her code fits into the whole picture. Observability and the development process represent this beautifully high potential virtuous cycle in the whole process of shipping software. And developers have the most to gain. The more you look at production, the more you build up that ops sensibility, the more the code that they write is going to be incrementally more ready for prod. Because observability is more than just 3 types of data. It's more than just a tool chain. It's about the culture and the processes of the team that supports this and how that entire organization thinks about production. So, okay, what does it actually look like when developers are able to think about observability as a superpower? I'm going to say a few things. I think it means developers learn to speak the language of production. They can see through production and how it maps to their code. And they can start to run experiments and check hypotheses. We're going to take a closer look at each one. When developers can speak the language of prod, it means they can understand innately what's happening in production, or understanding what our tools are telling us in production, since that's the primary way production speaks to us. But this doesn't always happen naturally. Sometimes you actually have to teach production to speak the language of developers. Because tools don't naturally, or I'll say traditional monitoring tools, often don't naturally speak the nouns I care about, or I as a developer deal with day to day. They assume they care, traditional monitoring tools often assume that their users care about a certain set of nouns that don't tie back to the code, that don't tie back to the things that developers can control. And having that ops person from my past come to me really frustrated that CPU utilization is up on a certain set of Cassandra nodes doesn't actually tell me very much about how to go about diagnosing it, much less fixing it in my IDE. Contrast that instead to some of the nouns that developers do deal with day to day that trigger different behaviors in the code itself. And instead, instead of being yelled at about Cassandra CPU utilization, I'd been told, like, hey, Christine, latency seems up ever since that a deploy went out with a build that your code was in on a particular endpoint for our largest customer. All right, well, that immediately tells me how important it is, something about the conditions under which this behavior is happening, and also what sorts of things I might be able to change or tweak to fix it. And for developers, the metadata that we use to sort these sorts of things out are almost always high cardinality data, because these are the nouns I'm dealing with day to day. This is what captures the characteristics of whether something goes through this path in my code or that path. And these are the nouns I want to slice and dice by. Whoop. Great. I'm going to say again, support for high cardinality data like this matters because it's what lets developers dive into data and understand the why and understand the under which conditions rather than just the what. To ground this in reality, build IDs is one of my favorite stealth high cardinality attributes, right? Seems like a fairly maintainable small number. It's an integer, it must be safe. It can also grow in an unbounded way. But it's also one of the most useful. This data set is one of our data sets in dog food that describes the behavior of our web app. And the second starter query that our engineers configured is, simply put, has the code I care about been deployed to prod yet? The final piece here is our instrumentation, our systems are constantly evolving, much like language. And if our instrumentation is meant to provide visibility into those evolving systems, we have to make sure that our instrumentation is able to keep up and evolve along with it. A lesson that we learned, again, in testing is the easier you make it for devs to write tests, the more they'll do it. Great. Let's make instrumentation as easy as possible to add. Let's make it like adding a comment in your code so that folks can always describe what should be happening and what is happening in production. Because all of these things are what lead to production not feeling like some big, dark, scary place out in the ether, but instead just like an extension of home, of where you do feel comfortable. Okay, seeing through production to the code. When I say something like this, I mean being able to see the shapes and workflows that really help map something that you're seeing in production to the code itself. Tracing has blown up a big way the last few years, right? Very cool. Marketing teams have done a great job of convincing you that tracing is a high-tech, absolutely brand new development. Distributed tracing for modern microservices teams. Very true. Also true. Tracing is just as good for monoliths and intra-process visualization as it is outside. Because tracing is one of the most developer-friendly evolutions in our industry yet. One look at a trace, and you immediately start to understand how your code is actually executing against this production workload and when your code is executing. Someone told me recently that it's like Chrome developer tools for non-browser software. Which, yeah, in a way, this is true, absolutely. But how exciting is it to be able to connect this very developer-friendly, developer-native kind of feel and visualization to what we're seeing in production, to what the ops and SRE folks are using in production. Because what we need to be able to do, once we've gotten down to this very granular individual request, is be able to understand it in the context of our system as a whole, to be able to pick out its impact, and be able to pick out patterns in our overall system. Because investigating a production system should feel like the way we investigate anything, right? Start at a high level, you have some hypothesis, you're like, this doesn't look quite right. You zoom in and you iterate and you isolate until you can find a specific case or specific set of cases, something of this expectation deviating from reality. And then, great, now we're at the stage of a trace. We can find specific requests, specific instant, zoom in to really understand how the building blocks fit together. But then you repeat, right? You should be able to, instead of just ending up at the trace, you should be able to use what you've learned, continue refining your investigation, continue this exploration. And the thing that's so exciting about Chrome developer tools for non-browser software is being able to combine developer friendliness with these powerful query engines and this powerful investigative flow so that we can find the most interesting traces that tell us the most about our systems to drive that virtuous cycle. And the last bit of the superpower, so much of software development relies on an understanding of what's normal, right? What is our baseline, what we expect the workload to be. And the more that we can base our understanding of what is normal, especially when we're writing new code on real production workloads, instead of, for example, guesswork, assumptions, product manager intuition, the more certain we can be that the software that we write will behave. Sometimes it's as simple as, okay, great, I get a task assigned to me, support nested JSON and payloads. I know how to do this, I can build this, I can roll it out, get it through code review, ship it. But wait, what if instead, before I spend the time writing the code, spend the time of my teammates getting through code review, what if instead we ask things like, well, how many people are sending us nested JSON right now? How many people are relying on that old behavior? What would happen if I ship this? Can we answer that? Do we know? The more we can ask those questions, and the quicker it is for the engineers to be the ones to ask them and not the product managers, although I know product is a discipline, the more we can make sure that we're writing the right things in the first place and have the impact on our users in production that we want. It's really, really exciting when we hear about organizations moving beyond just thinking about monitoring and observability as something that happens when you have an incident or what happens as a result of an outage. So shout out to our friends at GeckoBoard who have moved way beyond this in a very exciting way. They were telling a story recently about how they were working on a new feature that essentially reduced to the bin packing algorithm. Right? It's a known NP-complete problem. They could have sent an engineer or two to come up with a perfect theoretical implementation based on an understanding of what the inputs should be. But instead, they were able to quickly prototype 3 different implementations of it, push them all to production, captured how each algorithm performed, and then threw away the output. And in this way, they were able to really quickly measure which implementation actually worked the best for their intended goals. And move on. No wasting time, no angsting about what thing is more, theoretically more correct. And this is possible because their tools were able to support these ad hoc experiments, and their tools encouraged flexible instrumentation, and because their developers had gotten comfortable enough in production, gotten comfortable enough with these tools to actually run these experiments and to think about it first. And the final piece, it's really exciting how observability pairs well with some of these other techniques becoming so common in modern software development. Feature flags are awesome, right? It's incredibly powerful to be able to test code out on a very small amount of traffic. But it's even more powerful. You can then take the output of those feature flags, pump them into your observability tools, and then get access to those same high-level graphs we're used to each day, but for that tiny slice of the host I picked today, or the one customer I really care about, or an arbitrarily defined 1% of traffic to see how this feature flagged code behaves. And at this point, production is no longer the place that our development code runs after the ops people say it's okay. It becomes where our development process lives. And observability, the ability to ask new questions in a developer-friendly way, is key to all of this. For the final part of this rising action, if the Marvel Universe has taught us anything, it's that superheroes are better together. And this lesson is especially true for developers who are still getting a handle on these new powers. Here is an indisputable truth. All debugging is a social act. Because the simplest version of this is past you learning something that helps present you investigate something today that then future you can do faster. For the rest of us, there's social and there's a team and you have an on-call rotation. Because I'm just never going to be as good at debugging a Kafka issue as a real ops person. But if I can peek over the shoulder of an expert and see how they tracked down a similar issue last week, it gets me a whole lot closer than trying to figure it out myself. I think last Monitorama, I think it was Logan, again from Mapbox, stand on stage and describe being new to an on-call rotation as, and watching an experienced on-call engineer as someone making leaps of intuition akin to magic. Maybe it is. Maybe it's actually just a sufficiently advanced technology. And the key is for someone to use that sufficiently advanced technology in a way that is learnable and shareable instead of impenetrable. A lot of the techniques that we use in this industry to transfer knowledge rely on kind of active participation and really good intent. Postmortems, documentation. But there's an opportunity for passive knowledge transfer as well, right? Chat ops, Slack bots are part of this. But also things like tools keeping your history around. Ways for experts to leave a paper trail or show their work so that non-experts can peek over their shoulders and learn at their own pace. Because this is how we build up our superhero team. This is how we lower the barrier to on-call rotations. And this is how we bring everyone up to the level of our best superhero, debugger. Now, if this talk really was a superhero movie, after the scene setting and the awesome getting our powers montage, this is where we'd blow about a third of our budget on 20 minutes of CG and fighting and lots of special effects. But the whole point of this exercise in our real life is to actually reduce that sort of tension and release. We invest in these superpowers, and we invest in the superpowers of our team in order to reduce the number of battles we have to fight. or to prepare well enough for those battles, they don't really feel like battles anymore. They sort of just feel like our day-to-day. When we fold observability into our development process, we can make sure that we ship code more confidently. And we know that we're not going to have any surprise rockets along the way. Because no one can live the ups and downs of these blockbusters week after week. That way you get alert fatigue, burnout, teams rotating, teams turning over. And so, having gone on this journey together and having sidestepped the giant CG money fest, it's time for the obligatory Batman brooding over Gotham City montage, in which we reflect on what our recent adventures have taught us, right? If you're an ops or an infrastructure engineer, think about how you can empower your developers to share your responsibility and to share some of this power. Look around at your tools and your processes and think about what things maybe don't feel natural to someone who's used to living in a land before production, who's used to just writing tests, pushing them through CI. And look for opportunities to show developers, to tempt them with the power that they could have, so that they learn how observability can benefit them and why it's worth venturing out into the dark space on the other side of the Bifrost Bridge. If you're a developer, remember that these superpowers are possible and within your grasp. Because we all need to stop writing software based on our intuition and start grounding it in reality. Start backing it up with data. Because we can all have superpowers now. When we look for opportunities to get more folks comfortable looking at what's happening in production, we can all learn from how that code is going to behave, we ship better code, we deliver better experiences to our users, and we'll actually feel like that superpower helped get us there. It's the end. If you have any questions, there are a bunch of things I wanted to include in here, but couldn't because of spoilers. So come find me afterwards. I'd love to tell you stories and talk about superhero movies. Thank you. No questions. Okay, that's okay. I don't know if anyone.
It's very definitive.
Okay, great. Well, if you have questions or if you want to argue with me, please find me afterwards. I will be around.
All right, one more round of applause for Christine.